Hello everybody and welcome to another enVision's Algebra 2 video. In this video we're going to look at topic 4, lesson 5, example 5, solve a rate problem. So in example 2 we saw a work problem, and in this example we're going to solve a rate problem. So work, you usually looking at a ratio or a rate, hence a work rate problem. So you're going to look at how long it takes somebody to fill a pool or paint a wall or things like that. So it's usually like a room over time or a pool over time or things like that. And this one, we are going to look at distance equals rate times time type of problem. So we're going to be given a distance and we have to, or a time or a rate, and we're going to have to manipulate it so that we can solve for a problem. And usually these problems have you walking somewhere. In this case, we're paddling. This is where you get those trains going at different directions type of problems. These are those stereotypical algebra type problems. So right now we're looking at paddling with a current in a river. Jake traveled 16 miles. So now we have another variable. We have the variable current here. Even though he paddles upstream for an hour longer than the amount of time he paddled downstream, Jake could only travel 6 miles against the current. In still water, Jake paddles the rate of 5 miles per hour. What is the speed of the current in the river? So we're going to take his paddling to find out what the speed of the current is. So let's think about this. He has two different things. He has upstream and he has downstream. So we have distance, rate, and time. It looks like Jake traveled, so paddling with the current in the river, Jake traveled 16 miles, even though he paddled upstream for an hour longer than the amount of time he paddled downstream. Jake could only travel 6 miles against the current. So I'm going to say that this distance upstream is 6 and downstream is 16. Okay, the rate that he is paddling, so he's paddling in still water, that means there's no current. He paddles 5 miles per hour. So both of these have at least 5 miles per hour. But one of them is working with the current and the other one's working against the current. So downstream, I'm going to say he went with the current, and upstream he's going against the current. All right, so our time is going to be distance over rate, which is going to be 6 over 5 minus c, and this is going to be 16 over 5 plus c. And what we know is that the total time they took was, I believe, 1 hour. Even though he paddled upstream for an hour longer than the amount. Oh, he paddled upstream for an hour longer than the amount of time he paddled downstream. So it took him an hour longer plus 1 hour to paddle upstream than it did to go downstream. So, oh, it's downstream. Sorry, let me add the hour to the downstream. That was upstream. I should read my words. All right. So now what we're looking at is that to get the same distance or the same time, we have to add an hour for a current, add an hour for a rate. All right, looking at this, my least common multiple is going to be 5 plus c times 5 minus c. And we have no other, this is divided by 1, so we have no other factor in there that's not like these two. So here I'm going to look at 16, 5 minus c, plus 5 plus c, 5 minus c, because again, 1 times this will be that, equals 6 times 5 plus c. Looks like we're going to have a quadratic to solve here. So we get 16 times 5 is going to be, I'm going to use my calculator just so I know I'm accurate, 80 minus 16c plus 25. This is a difference of squares, so we're just looking at a minus c squared equals 30 plus 6c. So remember, difference of squares, if I have a minus b times a plus b, this is equal to a squared plus, not plus, because a negative times a positive is a negative, minus b squared. All right, so now let's just combine like terms. We're dealing with a quadratic, so we want to make sure that this is equal to 0. I could have subtracted that c to the other side. Oh, then we have 25 here, plus 25 is 75. And that is negative 32 or 22. Let's see. Okay. Pull out that negative. Basically, I'm just going to divide by -1 on both sides. So we get c squared plus 22c minus 75 equals 0. Okay, two factors that multiply to give me 75 and also give me 22. So I'm going to think of the factors of 75. Well, 75 is going to be 3 and 25. This is negative, so one of these has to be negative. One of them has to be positive. So if I do 25 minus 3, I get 22. So through c minus 3, c plus 25. So in our case, the current is equal to 3 or negative 25. Now, I made a big error at the very beginning. I did not say what c cannot equal. So c here cannot equal plus or minus 5. C cannot equal plus or minus 5. And in our case, our current is 3, so, or negative 25, but we really don't see a negative in speed. We do in velocity, but we don't see it in speed. So our current is perfectly fine, being 3. And I'm going to say, I believe the units are miles per hour. Yeah, 3 miles per hour. So what we want to say is the current of the stream is 3 miles per hour. Okay, so there we go. Solution here. Again, they're telling you how to break it down. I like breaking mine down into tables, or, I mean, this is really a table, you just don't see the lines, or things like that to get myself a visual cue on what I'm looking at. They just threw it straight into the equation. They computed it. We can't have a negative current or speed. You could have a negative velocity, but you cannot have a negative speed. And so the current is 3 miles per hour. All right, so you're looking at 3 people are planting tomatoes in a community garden. Maria takes 15 minutes to plant the garden alone. Benito takes X minutes and Taylor takes X plus 15 minutes. If the 3 of them take 20 minutes to finish, so this is not a distance equals right times time. This is exactly like that painting one that we saw in example 2. So you're going to put gardens over time. So in our case, Maria, for one garden, it takes her a rate of 1 garden per 50 minutes. Well, Benito, it takes 1 garden per X minutes, and Tyler, it takes 1 garden per X plus 15 minutes. If the 3 of them work together, it takes 20 minutes, so all 3 of them together, so 1 over 50 plus 1 over X plus 1 over X plus 15 will equal 1 over 20, and that will tell you how long or what x is, and then you have to add 15 to that to find Tyler's time alone. All right, guys, I will catch you in the next video, and I hope you have a fantastic day.